Hello everyone, hope you all are doing good. This video on slurry dewatering is a continuation to the videos on rotary kiln. As you all know, there are three different process of cement manufacturing: wet manufacturing technique, dry manufacturing technique, and semi-dry manufacturing technique. In all these three processes, the raw material goes through different steps before entering into the rotary kiln. And prior to entering the rotary kiln, the raw material is dewatered or pre-drying is done, and it is a very important step. Usually, in earlier days, in way back when cement industry was introduced with the rotary kiln, the rotary kiln used to be very long in length because the raw material was fed into the rotary kiln directly, and dewatering or pre-drying to sintering all was done in the rotary kiln itself. But now in modern cement industries, they are using preheaters and pre-calciners before rotary kiln. The material enters preheater, then it enters pre-calciners, then it go to rotary kiln, and subsequent amount of heating is done in this preheater and pre-calciner, and the length of rotary kiln hence is reduced because of using this preheater and pre-calciner, which you will see in the next video. Let's start with this dewatering. There are generally two ways to reduce water content in the slurry, and it can be done chemically or mechanically. Chemically means you have to add something into the raw mix, that is by addition of slurry thinners, and mechanically by slurry dewatering using proper filters, drum or disc filters made up of ceramic material. Also, filter presses are applied which form briquettes with a water content of about 18 to 20%. However, this requires additional cost. There are various mechanical instruments which can remove water from the slurry and convert that slurry into cake. And we are talking about wet process here, because in dry process there is no water involved. You do not need any dewatering. You just have to pre-dry it. But in wet process, the slurry from the silos is should be pumped into rotary kiln, and it cannot be pumped in the form of slurry. Hence, dewatering of that slurry is done. All the water, that slurry is taken into a filter press or some press where the slurry is converted into cakes, and all the water is removed, and only 18 to 20% of moisture is allowed before the material enters into the rotary kiln. Mechanical slurry dewatering allows for shortening of the long wet process kiln. Means if you are dewatering your slurry, it can reduce the length of the rotary kiln. Means rotary kiln has little work to do if this is done prior. Then how it is done chemically? Chemical dewatering of slurry by addition of slurry thinner is some amount of alkalis are added into the slurry. So we'll see what are those alkalis. Slurry thinners are added to the cement slurry to reduce the water content. Each percent of water reduction in the slurry increases kiln capacity by about 1.5%. Each percent means if you are removing 1% of water from the slurry, then you are improving the kiln capacity by 1.5%. Simultaneously, the heat requirement for clinker burning drops to 1%. So you can see how significant this is. If you are doing this slurry removing, if you are removing slurry, you are increasing the kiln capacity by 1.5%, and the heat requirement for clinker burning by 1%. So pretty good. So there are two groups of slurry thinner. One is alkaline electrolyte like sodium silicate, or also called water glass, sodium hydroxide, sodium carbonate. And another type is a surface active, mostly organic substance like lignin derivatives, humic acid, sulfite, liquor, calcium, lignin, sulfonate, carbonaceous additive, molasses. So what these two do is, these thinners, how they act is, they act as deflocculant. I hope you have studied what is flocculant and deflocculant while you are studying whitewares, I think. The ions of molecules of the slurry thinner are adsorbed on the surface of raw mix particle in the slurry. The adsorption process prevents agglomeration of particle, thus reducing the internal friction and increasing the flowability. So what happens is, suppose this is a particle of your raw mix. Some these alkaline electrolyte, when they are in water, they split up. This Na becomes Na2 plus, it becomes ion, and CO3 becomes some another ion. So what happens is, these Na2 plus or CO3 plus, they go and absorb on the surface of this raw mix, that is your raw material for cement manufacturing. They absorb and they carry positive charge or negative charge. Now another raw material particle which also carries positive charge will be repelled by these two are repelling, hence it keeps them in suspension. It keeps them in suspension. This is what deflocculation is. Deflocculation means the material keeps the colloids or particles in suspension. So this is what it is. So by this principle, these slurry thinners are used. Then after chemical dewatering, you have mechanical dewatering of slurry. In mechanical dewatering, we will be seeing chain system, which is a very important thing in rotary kiln. While explaining the parts of rotary kiln, I have showed you this figure, and I had told you that I'll explain this separately. These are the chain system. Usually chain system are not a mechanical dewatering device in a true sense, means it will not dewater by pressing it or something, but since they perform a substantial amount of mechanical work in addition to drying of the slurry, they are often classified as mechanical dewatering device. Means they actually do not dewater the raw material which enters into the rotary kiln, but still they are considered dewatering system, because they substantially do some mechanical work where dewatering is happening. So we will see what are the types of chain system. So there are two types usually, and that is first one is curtain chain. Curtain chain means, you can see this figure, the chains are in the form of curtain, right, straight. And another one is chain garland. You can see the chains are in the form of garland. You can see the actual picture as well. This is chain curtain and this is garland. Okay, now what is the difference between them, and what are their features? So this chain system you are seeing, the longest chain should be 0.7 of the diameter. The length of this chain should be 0.7 times the diameter of this rotary kiln. And here the longest chain should be the garland, the curve of the garland should be 0.4 per 0.4 of the diameter, means it should be upon 0.4, means this is 0.6 of the diameter of rotary kiln, right. So dry process rotary kiln are supplied generally with curtain chain throughout. In dry process, the chain are throughout the rotary kiln, right, they are throughout the rotary kiln. And chain section for wet process rotary kiln are a combination of garland and curtain chain both, right? Garland, and here only you can see curtain chains here. Here it is a combination of garland and curtain chain. You can see these are the garland and these are the curtain system, right? One or two chainless section are applied along the chain zone with the aim to equalize gas temperature, serve as a buffer area to equalize varying rates of material transport, precipitate kiln dust, allow for installation of thermocouple. So now why this chain system is present in rotary kiln is this chain system does so many serves so many purpose. One is it retains some gas velocity, it retains the gas in heat, it retains the heat inside this, inside between the chains, right? It retains the heat between the chain, and it suppresses the dust, which a lot of dust is created in rotary kiln. It suppresses that dust also, right? And it serves as a buffer area to equalize varying rates of material transport. Means it acts as a buffer area when the rate of input or when the rate of output is varying, right? These are all the purposes. It is usually the main purpose is to have good heat efficiency. It segregates the heats in parts, right? It does not allow the heat. Suppose the burner is here, and if there are no chains here, the heat will just pass through like this. But if there are chains here, the heat takes lot of time to pass through this, right? This is common sense. If there are no chains, the hot gases will pass through very easily, right? The material is entering from this side, the burner is this side, so hot gases will enter from this side. If there are no chains, it will pass through very easily. If there are chains, the hot gases will remain for some time, and better heat exchange between hot gases and the raw material occurs during this. So garland chain conveys the material in kiln more efficiently than free huge chains. This is of special importance for wet process kiln. However, chain curtains are easier and faster to install than garlands. Garland system conveys the material more easily and efficiently in the rotary kiln, but it is little difficult to install. You can see garland system, there is lot of area, lot of scope for the material to pass through easily. But if you see in curtain system, the chains are very close to each other. It is a little difficult for the material to pass through this chains compared to the garland system. Weight of the chain. For a clinker production of 1 ton per 24 hours, the following chain weight is used. In wet process, it should be 120 kg. In dry process, it should be 105 to 110 kg. Modern rotary kiln supplied with such chain system will show the following heat consumption. How much is the heat consumption if you are using chain system? For wet process, it would be around 2080 to 1430 kilocalories per kg of clinker. For dry process, it would be 1980 to 1130 kilocalories per kg of clinker. Now, when these chains are there in the rotary kiln, as the material pass, as the day goes on, it may get weird. Means lot of abrasion is happening because the material is passing through the chains, and it is obvious that the chains would get weird. मतलब wearing होता है उसका, थोड़ा थोड़ा चेन पतला होते जाता है, राइट? क्योंकि उससे बहुत सारा मटेरियल उसको रब करके पास होते रहते हैं, तो चेन थोड़ा 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 पतला होते जाता है. तो how thin it is getting means how much is the weight loss per ton of cement production. The wear of chain is in long wet process rotary kiln is in the range of 100 to 150 grams per ton. ओके तो 100 to 150 ग्राम्स चेन का वेट लूज होता है पर टन ऑफ क्लिंकर, तो इतना वेयर हो रहा है. फॉर लॉन्ग ड्राई प्रोसेस किल्न शोज अ चेन वेयर रेट ऑफ 80 to 120 ग्राम पर टन ऑफ क्लिंकर. सो दिस इज द wearing rate of the chain. Okay. Then comes the chain material. As you know, the temperature in rotary kiln varies from say about 400 degrees Celsius to around 1500 degrees Celsius. So it is quite a hot place, and your material needs to withstand that heat and the abrasion which the raw material causes on the chain. Hence, for temperature below 530 degrees Celsius, steel should be selected that can heat treated and hardened. So, in maybe in a drying zone or preheating zone, you can have chains made up of steels that are heat treated and hardened. Okay, as you move beyond the preheating zone, for the temperature from 530 to 640 degrees Celsius, hardenable high chromium stainless steel can be used. So in this temperature region, I hope you all know the zones in rotary kiln and the temperature profile of the zone. What is the temperature profile in say preheating zone, then burning zone, calcining zone, then sintering, liquid formation, and cooling. Then as we move further, for temperature in the range of 640 to 800 degrees Celsius, the chain should be made up of 18 chromium 8 nickel stainless steel. Means 18% it is an alloy which consists of chromium, nickel and stainless steel. 18% should be chromium, 8% should be nickel, and rest should be stainless steel. Then in the range of for gas temperature from 530 to 900 degrees Celsius, you have another stainless steel recommended. The number ASTM number is given here. For application over 970 degrees Celsius, a alloy with high chromium nickel content, preferably of high hot strength, should be used. So these are the material requirements for the chain system. So this is also pretty important. Okay, this completes the chain system. This is all about the chain system, and the gap between each chain and how the chains are mounted is all given in the textbook. You can go through the details if you want. I have not included all those details here. So you can see the gap here, right? These gaps, the gaps between two chains and the gaps between two rings, everything is given into the book. You can go through the book. And tomorrow, maybe in next video, and also I wanted to tell you that this completes your module 2, except for one topic, that is advances in cement manufacturing, which will be given as an assignment for you guys to do. And in next video I'll start from module 3, that will cover preheating and pre-calcination, preheaters and pre-calcinations. Till then, thank you.